Welcome to Preeminent Test Prep. Today is day 4 in our 90-day SAT preparation series. So today we are going to start with 30 minutes in the math section and then do 30 minutes on the writing section. So we're going to start with a review of yesterday's content. So yesterday we reviewed about 6 or 7 or 8 equations, and they covered starting with the complex conjugate. So that's where we're going to start. We're going to spend about 5 minutes reviewing what we learned yesterday, and then we'll get into some new math equations, and that will kind of round out the equations that I have set up for us this week. So to review our equations from yesterday, we had imaginary numbers to start us off. So we had imaginary numbers. So we have I. I represents an imaginary number, and we know that I is equal to the square root of -1. Right here. So we have I squared then, since the square root of -1 is equal to I squared would be the square root of -1 times -1, the square root of -1, which means that I squared is -1. So that's really the key part that we needed to know from the complex conjugate, is that I squared equals -1. And then we need to use this rule right here, this a plus xi times a minus xi equals a squared plus x squared. So that's how we can get rid of this imaginary number, right? By multiplying by that conjugate. So we have an a plus xi times an a minus xi. Our middle terms will cancel. We'll be left with a squared plus x squared, and that I term is going to cancel. All right, so then we got into some financial models. So the financial models that we started with was exponential growth and decay, and I also mentioned that that was a science model as well, right? You'll see exponential growth and decay a lot of times with carbon-12 and radioactive dating, so that can also be a science equation. So we have our equation is y is equal to a times 1 plus or minus r raised to the power of x, where a is our initial value or our starting value, and r is our rate of growth if it's positive, or our rate of decay if it's negative. Keep in mind, if we have a rate of decay, then we're going to have 1 minus whatever r is, and if we have a rate of growth, we're going to have 1 plus whatever r is. And then we have x as our unit of time. So the next equation that we had was financial models. So now we get into pure financial models. These aren't science models. And we have types of interest. So we have two types of interest. We have simple interest and we have compound interest. So the difference between simple interest and compound interest is that with compound interest, the interest that you pay, say in 1 year, then gets added on to that next year's total principal amount. So then you're adding interest onto the interest that you owe. Now in simple interest, you're not compounding, which means that if you were owed, say you owed $50 in interest after your first year, you're not charged interest on top of that interest, right? So with compounding, you get interest on interest, and with simple interest, you do not. So simple interest, our equation is going to be A is equal to PRT, where P is our principal amount, right? So if you had a loan, that would be the amount that you took out in your loan. So if you had a $1,000 loan, your principal amount is $1,000. R is going to be your rate of interest, right? So your interest rate. T is going to be your unit time, right? So if your interest rate is 5% each year, then your time is going to be 1 year. Then we got into compounding interest, right? So compounding interest, what's our equation for that? Well, for compounding interest, our equation is going to be A is equal to P, which is once again the principal amount, times 1 plus the quantity R, R being our interest rate, and then all divided by N, N being the number of times that that interest is compounded per 1t. Keep that in mind, that's per 1t. So N is the number of times it's compounded per 1 unit time, where t is time. All right, so now we get into statistical analysis on the SAT math section. So we have really only one equation that's specifically statistical analysis, and that is our mean or our average, right? Our mean is the same thing as our average. Now our equation for that is our sum divided by our count, right? Our total over our count. So the analogy or the example that I gave for that one was if we had a graph, like shown right here, of number of people and age. So if we're looking at this graph, we see that we have number of people on the y-axis, age on this x-axis, if you will, of a little plot here, right? So if we see that if we were going to find the average, we would have to do that 10 right here, because we have age 10 times 3 people, which is 30, plus age 20 times 1 person, that gives us to 50, because 20 times 1 is 20, 20 plus 30, now we're at 50, and then that 5 times 1 gives us 55. Then we divide that by our total number, which is 5 people, to get our average age of 11 years old. All right, so then our next concept was not actually an equation, but it was random sampling. Now, if we think back about random sampling, I said that random sampling, the goal of it is to create an unbiased and a reliable sample from which data can be accurately determined, right? We want to have an unbiased and reliable sample, because if we do that, then we can draw conclusions from the data. If our sample is biased, then our conclusions are invalid. So the example that I gave for random sampling is if we were asked to find the average children per household in a city, right? But let's say that we took that from a playground. That would be a biased sample because it isn't random, because people at a playground are likely to have larger numbers of children per household, right? So the next thing that we covered was random assignment. So random assignment, we already have a random sample at that point, hopefully, if we're doing this correctly. So that random sample is unbiased, but we have to keep it unbiased, right? So we have our sample, we know who we're going to collect data from. Now we have to determine how we're going to collect the data. So what we need to do then is we need to randomly assign people to different groups, right? If we aren't randomly assigning people to different groups, then we don't have random assignment. So the whole point of random assignment is to randomly assign people to different groups. All right, and then the last part we had for statistical analysis was standard deviation. So you didn't need to know the formula for this, but you needed to understand it as a concept. So if we look at our two plots of data here, if we were asked for the one with less standard of deviation, we know that it would be number 1, because we see that we have the deviation from our mean or our average is much less than the deviation from our mean or average in plot 2, right? Plot 2 has a greater standard of deviation. All right, so now we can go ahead and get into the formulas for today. So that is our review. So I'm going to go ahead and draw a line across. And now we've got day 4 SAT math. Okay, so today we're going to get into some trigonometry and some geometry. So we're going to be talking about circles, we'll be talking about the cosine, the sine, and the tangent, triangles, squares, anything like that. So we've got day 4 SAT math. Remember that this goes in your notebook, so we'll go ahead and start with geometry. Right? So we'll do geometry first, and then we'll get into some trigonometry. All right, so the first thing we're going to do with geometry is I'm going to teach you an equation that is helpful to save time. So this equation, you don't have to know it to get answers correct, but it will save you time, which is very important on the SAT math section. So I'm going to go ahead and make sure that you know it. So this is an equation that you're going to need to really want to memorize. You don't, like I said, it's not necessary to get answers correct, but it's going to help you save a lot of time if you know this equation. So this is if you have an equilateral triangle. So an equilateral triangle would look something like this, right? And all the sides are the same, right? So all the sides are the same, which means each angle is 60 degrees. You could also see that written like this. Have a triangle, right? All sides are the same. If all angles are the same, then that also means that it's equilateral. So if it just looked like this, that means all those angles are the same, which means that it's an equilateral triangle, which means all the side lengths are the same. So all those side lengths would be the same. So if all the side lengths are the same in a triangle, what we're going to use for the area of the triangle then is going to be the square root of 3. And keep in mind that it ends right there. This doesn't include the next part. It's going to be the square root of 3 times one side. It won't matter because they're all going to be the same, squared, and divided by 4. Right, so we're going to take all of this and divide it by 4. So the square root of 3, we're going to take that, multiply it by the side length squared, and divide it by 4. And that's going to give us the area of a equilateral triangle. So keep in mind this isn't for any triangle. This is for an equilateral triangle. And the reason that that's going to save you a lot of time, I'll go ahead and show you real quick, because if you were given an equilateral triangle, right, and you didn't have this equation memorized, then you're going to have to find the height, right? So you're going to have to solve for the height, because we know that the area of a triangle that isn't equilateral and in the area of an equilateral triangle is going to be 1/2 the base times the height. But if we memorize our equation right here, we're going to save time because we don't have to solve for the height. We can just plug in the side length squared, right? Because we would have to derive the equation for the height if we were going to solve it like this. So we want to memorize this equation here. So I highly recommend memorizing that to save you time. So that's for an equilateral triangle. All right, so our next equation is going to be for the area, or I'm sorry, not the area, the equation of a circle, right? So circles, they do have equations, right? It's not as simple as a slope-intercept equation. It's a little bit more complex, but it is still an equation. So we've got our circle equation. So this is the equation for a circle. If we're going to plot a circle on a graph, this is what it will look like. So we're going to have r squared, where r is our radius. So radius squared, it's going to equal x minus h squared plus y minus k squared. And once again, hk is going to be our center. right? So HK will be our center. HK is center, R is radius. So keep in mind, one thing that you'll probably see on the SAT math section if you're asked for a circle equation is you may see an answer choice that has R but R isn't squared, or you may see an answer choice that has the diameter squared or the diameter. So make sure that you're really focusing on having that R squared value. The next thing that you'd probably see is you'd probably see a flipped sign, right? You'd probably see a plus here or a plus here or a minus here. So make sure that you have this equation memorized accurately, right? We want to always know it's R squared equals X minus H, where H is our center, right? So if H is positive X, let's say that it's 3, then we'd have X minus 3. If H was negative 3, then we would have X plus 3 because it would be minus negative 3, which would give us plus 3. All right, so if H is a positive X value, we're going to have X minus H, and if H is a negative X value, then we will have X plus H, right? We're always going to have this be a positive, so this is always positive, right? We're always adding right here, and then we're going to always add Y minus K squared, right? So if K is positive, we have Y minus K. If K is negative, we would have Y plus K. So make sure you have that equation down in your notes. Remember, HK is your center, R is your radius. All right, so now we're going to have some trigonometry. So I'll draw a line through. That was your geometry. Now we get into some trigonometry. Trigonometry. I'm not even sure how you spell trigonometry, to be honest, so I'm going to quick look that up so I don't misspell it. All right, trigonometry. I believe that's how it's spelled. All right, so now we can go ahead and get into trigonometry. So we're going to be talking about sine, cosine, and tangent. So trigonometry, if you haven't taken trigonometry, that's fine. It's not too complicated, especially the way that the SAT has it. If you struggled in trigonometry and pre-calculus, or if you actually took trigonometry, or if it was taught in geometry, you should be okay because it's not anything crazy on the SAT. On the SAT, it's really just a lot of ratios. So the first ratio that we'll do, we'll just go ahead and do all three at once. So one thing that you can keep in mind here, and I'll just go ahead and put it down, is Sohcahtoa. So if your geometry or trig teacher didn't teach you this, it's a good handy trick. So why did I just write this series like this? Well, apparently from what my teacher told me, Sohcahtoa is like some Native American phrase or something, or a word. So that's just how you remember it. So what it means is that you have your sine of an angle is equal to your opposite side. Keep in mind that this is in a triangle. Right, so your opposite side from angle, opposite side from theta, all over your hypotenuse. Right, so your hypotenuse, if we were to draw a triangle right here, right, we've got our right triangle. Our hypotenuse, we'll say, is x, right? Our hypotenuse is going to be our biggest side length, right? So it's going to be the one that's opposite from our 90-degree angle. Right, so you're working with 90-degree angles. You've got your right triangle here. Keep in mind that these sines, tangents, and cosines, these are for right triangles only, right? We're only using these ones for right triangles. So sine, cosine, and tangent. So if we have a right triangle, we might have a question on the sine, cosine, or the tangent. So the sine is going to equal our opposite side from angle theta. So I'm going to call angle theta right here, all divided by our hypotenuse. So our hypotenuse is going to be x. We'll say this is y, and we'll say that this is z. So this is going to be our reference triangle as I answer these questions. So you want to put in your notes Sohcahtoa. So sine of theta is going to equal our opposite side from theta, which is going to be, in this case, y, over hypotenuse, which is in this case x. So cosine theta, that's going to equal our adjacent, right? If you don't know what adjacent means, it just means next to, right? So it's going to be our adjacent side from theta, all divided by our hypotenuse. So if we look at our adjacent side from theta, we see that that's right here, right? It's the side that's next to. The sine takes the opposite. So sine would be that y. That adjacent or that next to side is going to be our z here. So we see that we will have z over our hypotenuse. Once again, our hypotenuse is this x right here. So z over x would be our cosine of theta. So what about the tangent? So the tangent, if we go back up and we look at Sohcahtoa, we see that it's toa, which is an O over an A. That means we're going to take our opposite side over our adjacent side. So we've got our opposite side from theta, opposite side from theta, all over our adjacent side from theta. All right, so if we're going to look at our reference triangle that we made, we're taking the tangent of theta, then we are going to use TOA, so we're going to use our opposite, so that's y, over our adjacent, which is z. So we'll have y over z. Y over z. All right, so there's your sines, cosines, and tangents. I would make sure that you really have everything I just put underneath trigonometry so far in your notes, including the reference triangle, the Sohcahtoa, and all of these fractions, these ratios I put right here. I'd make sure you have all of that in your notes with that reference triangle before you move on. So there's your sine, your cosine, and your tangent. Keep in mind those are for right triangles only. So the next thing that you're going to need to be able to do, or we'll go ahead and include this right here. We can include the Pythagorean Theorem because we're already talking about right triangles. So we got the Pythagorean Theorem, right? So you don't need to know that it's called the Pythagorean Theorem. You just need to know a squared plus b squared equals c squared. So I explained this in our distance formula as well. And the reason it works for our distance formula is because when we're doing the distance, we can also view it as a right triangle. So let's say that this side here is A, this side here is B, then this side here has to be C, right? If we're going to use this equation, this a squared plus b squared equals c squared, keep in mind that C is always going to have to be our hypotenuse, right? So we're going to take our two smaller side lengths in our triangle to equal our hypotenuse squared. So let's say that A is equal to 8, right? So we have this side length is, we'll say 8 inches. And let's say our B is equal to, let's do 6 inches. And you'll see why I picked those in 1 minute here. All right, so we'll say B is 6 inches. So now we're asked for what is C equal to. All right, so what we're going to do is we're going to go ahead and plug it into our equation. So we have a squared. We see that a is 8, so we have 8 squared plus b is 6. So we're going to have 6 squared equals c squared. So 8 squared is going to give us 64. 6 squared is going to give us 36. And that's going to equal c squared. We know that 64 plus 36 is going to be 100. So 100 is going to equal c squared. We're going to take the square root of each side, and we see that the square root of 100 is 10. So we know that c then would equal 10. All right, so that's your Pythagorean theorem. So that's for that right triangle right there. We went ahead, we did that 8, that 6, and we found our answer. All right, so keep in mind that that's for right triangles, that Pythagorean theorem. All right, so now we can go ahead and get into the next equation. All right, so the next equation that we are going to do is going to be working with degrees and radians, right? So you're going to find this with circles. All right, so if we go back up to our circle equation, see if I can put a space in here actually to put it in. Does not look like I can, but I'll give it a shot. Yeah, it does. No, I cannot. Okay, so I'm going to, if you have room next to your circle equation, put it there. If not, then just put it down here. It's not a big deal. But if you have room by your circle equation, then put it there. All right, so we're going to have our degrees and radians. So we have to be able to convert from degrees to radians and from radians to degrees. So how are we going to do this? All right, so let's say we're going to do two scenarios. So we'll do if we have degrees, and then we'll do if we have radians. All right, if we have radians. All right, so let's say that we are given the degrees that we have. Let's say that we have 270 degrees, and we want to know how many radians that is. So in order to convert from degrees to our radians, we have to cancel our degrees. So we have to do divided by our degrees. So we know that there are 180 degrees for every pi radians. So if we're given degrees, we have to multiply then by pi over 180, right? So we take that 270, multiply it by pi over 180. We know that 180 could be rewritten as 2 times 90 degrees, and we know that 270 could be rewritten as 3 times 90 degrees. So I'll go ahead and show you how I would do this to simplify it without a calculator, because these types of questions could certainly, and most likely, I won't say most likely will, but they certainly could show up on the math no calculator section, so you have to be able to do this without a calculator. We can convert that to 2 times 90 degrees, because that's equal to 180 degrees. cancel our 90 degrees, right? And we're going to be left with 3 pi over 2, right? So that would be our number of radians. That is equal to 270 degrees. So the equation that you're going to want to put down for this is going to be our degrees equals, or I'm sorry, our degrees times pi over 180 degrees gives us our radians. So let's say that we had radians. Let's say that we have we'll say we have pi over 4. So we have pi over 4 radians. And we need to get to that 2 degrees. Well, we know that there are 180 degrees for every pi radians. So now what we're going to do is we're going to look to cancel things, right? So we see we can cancel our pi's. Right? So cancel our pi's out. And now we're left with 180 degrees over 4. And we know that 180 degrees over 4 is going to give us 45 degrees. So our answer there would be 45 degrees. So what's our equation for that one? Well, our equation up here was degrees times pi over 180 equals radians. So now we're simply going to flip our degrees and our radians. So we're going to have our radians times, keep in mind we also have to flip our pi over 180 to 180 degrees over pi. And that's going to give us our degrees. All right, so you're going to want to have this equation in your notes as well. Okay, let's see what else we've got. We've got polygons. So now we're going to go back to geometry. We are working with shapes once again. Polygons. What is a polygon? All right, so if you don't know what a polygon is, I am going to explain it to you right now. All right, so polygon, poly, the prefix means many. Gons, I don't know what it means. It probably means many sides because that's what a polygon is, right? So a polygon is a shape with many sides, so a many-sided shape, right? There's no limit to how many sides it can have, right? Like I said, prefix poly means many. We're working with a many-sided shape, right? There's lots of sides to it. So there can be different polygons. It can have 5 sides, 8 sides, 10 sides, 15 sides, however many it wants. So the equation then that we need to know for the SAT, right? Why does this matter for the SAT? We need to be able to determine the interior angle. Right? So we need to know the interior angle of a polygon. We have to be able to determine that. All right, so the interior angle of a polygon. How do we find it? All right, so this is going to be our next equation that needs to go in your notes. The equation to find the interior angle of a polygon is going to be n minus 2 times 180, all divided by n, where n, I'm sorry, that's equals interior angle of a polygon. Right? And I'll go ahead and show you as well what the interior angle is. All right, that's an interior angle, 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 and that's an interior angle. So those are going to be all of your interior angles on a polygon, right? There's obviously can be more on some, less on others, different angles. So that's that. Now in our equation, n is equal to the number of sides. Number of sides. All right, so you're going to take your number of sides, subtract 2, multiply by 180, and divide by your number of sides, and that's going to give you your interior angle of a polygon. Now, if we're going to use a really basic example, what we could do is we could go ahead and use a square, because a square is a polygon, it has 4 sides, and I'm just going to show you that this equation is correct real quick. We see an interior angle of a square is 90, right? We have 4 sides minus 2 times 180 all over our 4 sides. All right, 4 minus 2, that's going to give us 2. 2 times 180 is going to give us 360. 360 over 4, that's going to give us 90 degrees. All right, so now we've got our next equation. So the next equation that we're going to be working with is back to circles again. So if you have room by your circles, we're going to be doing more with circles. So this is going to be working with our radians and our degrees. So we're going to have 2 different equations here for the same, kind of the same thing here. So the first one we're going to do is called arc length of a circle. Right, so what is arc length of a circle? So if we have a circle, right, and that's actually a better circle than I thought it was going to be. So that's fantastic. So we have a circle, right? Here's our center of our circle. That's our circle. Let's say we want to know how long, let's call this point Q, call this point P, call this point Z as our center. Let's say we wanted to know the arc length of Z, or I'm sorry, of P, Z, Q, right? So, or I think that it would actually be written as arc length PQ, as I believe that's how, yep, that's how it's going to be written. So the arc length P to Q, right? So that's going to be this right here. We want to know how long that arc right there is, right? So here's our equation for that. We have arc length. We're going to have two equations. So the first one we're going to have is if we're using radians, right? So if we have radians, it's going to be our angle theta in radians multiplied by our radius. And that's the easiest equation. So if you're given your angle right here, your theta in radians, and you have the radius, use this equation because it's much, much faster, right? The other equation that we have is our arc length. Now I'm going to write here that that's in radians as well, right? So that has to be in radians in order to use this equation. So if it was, say that it was 180 degrees, you could convert that. You know that 180 degrees is equal to pi radians, so then it would be pi times the radius for your arc length. But if you're given it in radians, say that you're given pi over 2 as your angle, right, which is 90 degrees, so you're given pi over 2 as your angle, you could go ahead and do pi over 2 times r to get your arc length. So the other equation that you can use for arc length, if you're given your answer in degrees, or your angle in degrees, is going to be your angle, or your central angle. I'll go ahead and put central in there so you know which angle we're talking about. Yeah, central angle, all divided by 360 degrees, and then multiplied by your diameter times pi. Now what if you're giving your radius? If you're giving your radius, you want to use this equation here, right? If you're given radius and you want to use this equation rather than this one, then what you're going to do is go ahead and convert that to your diameter by multiplying by 2 as well. So those are going to be your two equations. I would definitely suggest using this top one right here if you can. So if you're given your angle in radians, go ahead and use this one. If you have your radius and you want to convert degrees to radians to use this one, go ahead and do that. Let's say, for example, that you were given your, let's say that you're given your radius and your central angle in, let's say you're given your radius instead of your diameter, and let's say that you're given your central angle in radians, go ahead and use this one. If you're given your diameter, let's say that you're given your diameter and you're given your central angle in radians, I would suggest dividing by 2 to get to the radius and then using this top one again. I think really the only situation where I would prefer to use this bottom one is if I'm given a central angle that isn't easily divisible by 360, right? So if you're given a central angle of 268 degrees, then that's not going to easily divide over 360. If you're given one that's say 57 degrees or any sort of odd numbers, anything really other than 90, 180, or 270, then I would suggest using the central angle one. But if you're given something like 90, you should be able to recognize, okay, 90 degrees is equal to pi over 2. I'm given the radius, so I don't have to convert to diameter if I choose to use this equation right here. So I'm going to do my radius times, I know 90 degrees is equal to pi over 2 radians, so I do my radius times pi over 2 there. So I would definitely prefer that top equation to save time. All right, so the next equation that we're going to do is going to be the area. All right, so we're going to be doing the area of a sector of a circle. So what is a sector of a circle? That's the first question we should ask. Go ahead and draw a circle. All right, we get our center right here. The area of a sector of a circle would be something like this. We've got our angle theta. We're going to call this point Z, call this point Q, call this point P. It would be this shaded region right here, right? So that would be what our sector of a circle is. If we want to find the area of that, the equation that we're going to use, we've got two of them once again. So if we're given our central angle in degrees, then the equation that we are going to use is going to be our area is going to equal our central angle divided by 360 degrees again, multiplied by pi r squared. So what makes this really simple as well, if you don't memorize this equation, is you can just think of it like this. If we have a circle, we know that the area of a circle is going to equal pi r squared. and we're dividing by the fraction that we're considering, right? Or we're multiplying by the fraction we're considering. So we're only considering the part right here, right? So that's that angle over 360. So that's another way that you can easily think about it. So if we're going to do that with the radians, I believe that it would be, let me make sure I'm right. Okay, so the area, if we're using radians, let's say central angle is given in radians, central angle given in radians. Okay, so if we're given our central angle in radians, the equation that we're going to use is the area is equal to 1/2 the radius squared times angle theta in radians. So that's in radians. So if you're given radius and you're given your angle in radians, that's the equation that you should use. So go ahead and put this one in your notes. Go ahead and put this one in your notes. So you should have both of those in your notes. All right, so let me just check if there's any other equations I wanted to cover today as I go through. I'm not seeing any other equations, but there is a couple tricks I should put in as well. All right, so then one trick that I want to put in is with triangles. So if you have room next to your triangle notes, put it there. If not, you can just add it down below. As long as you memorize everything, it won't matter what order it's in because you'll have it memorized. So you'll also don't necessarily worry about taking a ton of time out of your day to memorize it now because you'll pick up on it and gradually memorize it as we go through practice problems over time in the following weeks. All right, so triangles. There are really two triangles that you should know to save time on the SAT math section. First one's called the 3, 4, 5 triangle, right? So this is with a right triangle. So we've got a right triangle. That's a 90-degree angle there. Our hypotenuse is 5, one of the sides is 3, and the other one's 4. So if you're given a triangle that looks like this, you have a 5 here, you have a 4 here, you need to recognize that x right here is going to have to equal 3. If you're given a triangle that looks like this, that's a right angle, we have a 3 and a 4, recognize that this x here is going to equal 5. If you have one that looks like this, and let's say that you're given that you're asked for x right here, you're given 5 here, and you're given a 3 here, recognize that x has to equal 4, right? And here's why. 5 squared equals 3 squared plus 4 squared. We know that that's 25 equals 3 squared is 9, and then 4 squared is 16, right? So that's going to equal 25. So that's using that a squared plus b squared equals c squared, which is the Pythagorean theorem. I would make sure that you have written down this right here, triangles, 3, 4, 5, and then this right triangle right here that shows you that rule. All right, the next one that you're going to need to know is called a 5, 12, 13 triangle. A 5, 12, and 13 triangle. So how that's going to look is something like this. It's not really going to look like that because that would be way out of proportion. I'll try to draw a better one. And keep in mind, triangles don't have to be proportional on the SAT. It can say that it's not drawn to scale, and you'll just have to realize it's not drawn to scale. So it could look like that and still be a 5, 12, 13, but I'll try to draw one that's a bit more accurate. All right, so right here we'd have our 5, we'd have our 12, and we'd have our 13. So that's what a 5, 12, 13 triangle would look like. So what I was saying there is just that the SAT, they don't have to really draw it like that, right? You could have a 5, 13, and 12 triangle that looks like this, as long as they say that it's not drawn to scale. So if it says not drawn to scale, and it'll usually say that, not drawn to scale, because if they were drawing it to scale, then they'd have a problem with people if they were to like tattoo a protractor onto their arm, which don't do because that's weird, but they just don't do that because then they don't want kids looking at it, and some kids who have better eyesight being able to notice that it looks more like a 5, 12, 13 than say like a 4, 12.7 and 13. So they usually don't draw them to scale, and they'll usually say that it's not drawn to scale. So it could still look something like this. Oops, that's a 31. It could still look something like this when it shows up. And it could still be a 5, 12, 13 triangle as long as the numbers are there, right? Because it doesn't have to be drawn to scale. So if you saw 13, 12, you should know x here is going to equal 5. So those are just two types of triangles you should know for the SAT math section to save you time. So now we're about 35 minutes in. So we're going to be switching over to the SAT writing section. This ran a little bit long, but I'll try to keep the SAT writing section down to about 25 minutes to keep it at about an hour. So let's go ahead and switch over to that. All right, so let's get started with the writing section of the SAT for today. So we're going to spend about 25 minutes here. We're going to do the first 5 minutes reviewing what we learned 2 days ago on the SAT writing section. So that was our first day. So let's go ahead and start with the grammar rules that we learned 2 days ago. So grammar rules, first thing we learned, agreement and number between subjects and verbs. So that means that the number of a verb has to match the number of its subject. We had examples with singular and plural. So the first example we had was Joseph. Joseph jumps up into the air, right? So we learned that Joseph is singular, so we need to use a singular verb, jumps. Next we had Joe and John, which is more than one person, so that's plural. And we used the plural verb jump. So the big piece of advice I had there is if there is an S at the end of the verb, that can be dropped without messing up the base word, right? So the base word in jumps is jump. If there is an S at the end of that verb, that can be dropped, right? So if it was jumps, we can take away that S, and then that is a plural verb. Now, if that S is there, then it's likely a singular verb, right? If that S is on the end, then that is likely a singular verb. All right. Next thing we learned about was collective nouns. So collective nouns can trick you up. So collective nouns are used to group a collection of individuals or singular subjects into one singular subject. So the example that we had was Congress, right? Congress is a group of people, but we treat its subject as a singular, right? So we have our incorrect example, which is Congress are going to dismiss, because that uses singular Congress with plural are. So the correct example would be Congress is going to dismiss, because we have singular Congress and then a singular verb is. Next big piece of advice is to ignore prepositional phrases when determining the number of a subject and the number of a verb. So prepositional phrases, they're phrases that are modifying a subject and include a preposition and an object, right? So a preposition, I'll go ahead and remove some of this so you can see better, right? All right, so a preposition would be like an of right here or a with right here. We see that our prepositional phrase is of clarinet players, so we're going to ignore that when we're determining the number of our subject. Our subject's going to be band. Band is a collective noun, but it's singular because it's a collective noun. So we need to have a singular verb, is, right? So we have band and is, both singular. Next we have with the most basketball players. That is going to be our prepositional phrase there. We ignore it, come back here. We see we have our collective noun group, which is singular. Since it's a collective noun, we use the singular verb is to create that sentence. Next, we covered pronouns. So pronouns are used to replace a name or a subject like John. So we have the rules for pronouns. We have two big rules for pronouns. Number one, it must be clear who or what the pronoun is referring to, right? So we have to know who we're referring to. So if we were to say Jason and Joe run every day and he gets tired, we'd be breaking that rule because we don't know who he is referring to. Is it referring to Joe or is it referring to Jason? We don't know. So that's the problem there. It's unclear who that would be referring to. And then our second rule is that the number of the pronoun must agree with its subject, right? So we need to say Jason and John run every day, and they are going to run on Sunday, right? They agrees with Jason and John. They're both plural, right? We couldn't say Jason and John and then say he, because that would be breaking that number, right? They're both plural there. All right, next. We talked about types of sentences, right? We talked about simple sentences, how they contain one subject and one verb and form one complete thought. We talked about compound sentences, having two subjects and two verbs, right? You have two independent clauses. So you got two independent clauses connected by a comma and a fanboy. That's our first option. Or a semicolon, right? A semicolon and no fanboy. Or a semicolon and no fanboy is really what I'm going to leave it at there. And then we have compound and complex sentences. So a compound complex sentence, we have two independent clauses just like a compound sentence, but we also have one dependent clause. So how do we know if it's a dependent clause? Well, we talked about subordinating conjunctions. So that was this big list here. But basically how we can know it's a dependent clause is it can't be a sentence on its own, right? So it can't be a sentence on its own. So an example is right here, when he was on lunch break, right? When he was on break. That's not a complete thought. When he was on break, what happened? We don't know. So that's our dependent clause. So if we're going to write our example of a compound sentence, or a compound complex sentence, we have our first independent clause, the woman ate her breakfast, a comma, and then our and. So that's our compound part. We're connecting those with a comma and a fanboy. And then another independent clause, the man ate his lunch, and then a dependent clause, when he was on break. So comma splices, they are when we try to connect two independent clauses with only a comma and no coordinating conjunction. So there's no fanboy there. So we want to avoid that, right? So we want to avoid run-on sentences. We also want to avoid sentence fragments. So these are sentences that or things that have a subject and a verb, or don't have a verb and just have a subject, or just have a verb and no subject. Either way, they aren't complete sentences and they can't stand on their own because they aren't a complete idea, right? So even if it has a subject and a verb, it can be a sentence fragment if it doesn't have a complete idea or one complete thought. Then we talked about modifiers. We talked about how modifiers have to be placed next to what they're modifying, right? So our example we had was the world's brightest mathematician, comma, Jim Simons. And we also talked about how if it's introductory, which means it's at the beginning of a sentence, our modifier has to have a comma after it. And if we're going to put it in the middle of a sentence, we have to have those commas that keep it separated from the rest of that sentence, right? So that's called a non-essential, right? So a non-essential modifier, which means that we have to have commas on each side of it, right, if it's in the middle of a sentence. And it also means we know it's non-essential if that sentence makes sense without it. So if we were to take it out, we'd have Jim Simons is a genius, which is a full sentence. Okay, so that's our review of yesterday, or of 2 days ago. So now we can get into the fresh content for today. So today we're going to be talking about context to start off. So I'm going to switch to my highlighter and we're going to get through that. So we've got context. So context is everything with the SAT writing section, right? You want to know what's going on in the passage, not so much like you do on the reading section to answer questions about the actual passage, but so that you understand what's going on as far as verbs, numbers, tense, subjects, and parallelism, right? So I'll start from my first bullet point and we'll go down. So we got context is everything. So words in the passage have to make sense based on the context in which they appear. For the SAT writing section, there are a lot of times where you're going to have to decide whether or not a word should be changed or whether or not the correct word is being used, right? So this means that you have to read the passage because you have to have an understanding of what's going on with the tone. What's the author's tone? Because we want to match tone throughout the passage. We have to read the passage because we have to know what's going on as far as the verbs that are being used, the numbers of those subjects, the tense, because we have to match the tense of verbs, subjects, because we don't want to misuse, like I said, we have to match our subjects numbers to our verbs, and parallelism. And I'll get into parallelism later as well, because that's another bigger thing. So the type of passage, how we're going to read for the writing section is going to be a lot different than how we're going to read for the reading section. When we're reading for the reading section, we don't really care about grammar, right? But when we're reading for the writing section, we're focusing very, very much on grammar, right? We're focusing on, right, as I say, as you read, make sure that you focus on verbs, right? So what do I mean by that? Well, I mean that I'm paying attention to the verb itself. I'm paying attention to the tense of the verb, what tone is being consistent with the verbs, right? Because you could have a series of verbs and you have to maintain that tone that has gone on throughout the rest of the passage. So we want to pay attention to tone. So that way, if we have to match tone, we can do that. We want to pay attention to verbs so we know what tense we're in, right? We know what tense we're in. We want to pay attention to numbers so we can match it to our subjects. All right, we want to pay attention to parallelism, which I'm going to get more into later, but I'll just leave it at that for now, get into parallelism in a little bit. All right, so also as we read, we want to pay attention to paragraph structure. So why do we want to pay attention to paragraph structure? Well, there's questions on the SAT writing section where you have to place a sentence within a paragraph, which means we need to pay attention to the flow of ideas within that paragraph, right? We want to make sure that we're moving through the text or through a paragraph with a proper flow of ideas. We can't have a sentence that's misplaced because we'll be asked to go back and place it where it should belong, right? So we have to pay attention to the flow of ideas and to paragraph structure. What's this paragraph trying to accomplish? What is the purpose of the paragraph? All right, so here's some examples, right? If I'm reading and I read, well, John has, and then I have one word underlined. When I have one word underlined, I know that I'm probably going to have to replace that word or select no change, right? So I'm paying attention to the tone in the sentence, what the sentence is trying to say, right? And I need to know the context as well. I need to have read through the beginning of that paragraph down to there, or at least a couple sentences before it, in order to have a good idea of what fits with the tone and what this sentence is trying to say. Because if I'm missing context, I'm missing meaning. And in order to answer this question, I have to know what I'm trying to say, right? What I'm trying to advance in the text. So I'll read the sentence. I have, well, John has entertained the idea of imposing a speed limit of 33 miles per hour. He has not considered the increased traffic that will cause. All right, so the question type here is going to be on related or similar words, right? I know that's not a homophone down here, if you see where I'm circling, because entertained doesn't have a homophone, right? And I'll get into what homophones are as well if you don't know what those are. So, well, John has entertained the idea of imposing a speed limit of 33 miles per hour. He has not considered the increased traffic that will cause, right? So entertained here, it's not necessarily a terrible word, but there's likely a better word, right? So if I look through my options, I'm going to try to come up with my own word. Well, so first of all, the first thing I want to do before I even look at my options, just like with the SAT reading section, and keep in mind I have A through F here, but you're only going to have A through D on the SAT, and usually D will be no change most of the time. So really you're only usually going to be dealing with 4. I put A through F here just to give you an idea of how I can eliminate answers. So the first thing I'm going to do before I look at my answer choices is try to come up with my own answer. So when I read this sentence, I have, well, John has entertained the idea of imposing a speed limit of 33 miles per hour. He has not considered the increased traffic that will cause. So entertain here isn't terrible, but when I read it, what I think would be better is, well, John has proposed the idea of imposing a speed limit of 33 miles per hour. He hasn't considered the increased traffic that will cause. And here's why proposed, in my opinion, is a better word, right? Proposed. Because when you entertain an idea, let's think about if you're entertaining an idea, right? You're not really advocating it that much, you're just thinking of it, right? If he's just thinking about it and he's not considering the increased traffic that will cause, if he's just thinking about it and not considering that, that's not really an issue, right? He's just kind of brainstorming. The other thing that sets me up to think that this has to be proposed is this well statement, right? When I see that I have, well, John has entertained the idea, comma, this is kind of intriguing me as to this is going to be contrast, right? So think about it like this. If I was to say, well, the policy 333 may do some good in the community, comma, the next thing I'm going to say is going to contrast that, right? It's going to say why I don't think it should be passed, right? So for example, if it was, well, increasing the speed limit to 33 would decrease the risk of accidents, comma, it would increase traffic, right? I'm contrasting two things. So if someone is really arguing for one point and I have this well statement here, I know my next thing is really going to be trying to attack that point, right? And the only way that that really point is going to be out there is not if it's entertained, but if it's actually proposed, right? So we're going to have to propose that idea in order for it to be refuted like it is in this sentence, right? If we're entertaining idea, it's not really going to be refuted as strongly as if it's proposed. So that's telling me that the answer I'm going to come up with is proposed. All right, so that is the answer here, right? This isn't from an actual SAT practice test. We will do questions that are from practice tests later on in the prep course, but for now, I'm giving examples that I think teach the material the best. So right here, the answer is B, right? So the answer is B. But I'm going to show you how, if you didn't come up with proposed, how you could get rid of the other answer choices. All right, so here's one thing immediately that I can get rid of some answer choices with. I see I have, well, John has. Has indicates past, right? So if I have, well, John has sustain, sustain is present tense. So I can get rid of A. So I'll get rid of A. Well, what about entertain? Entertain is also present tense. I can't go from past to present. So I can get rid of entertain. I have entertained, that's in the past tense. Argued is in the past tense, and suggested is in the past tense. All right, so now I have it down to 4. So I look at my options. I already told you that proposed is the right answer, so I'm going to show you how I can get rid of the other ones. So argued. Well, John has argued the idea of imposing a speed limit of 33 miles per hour. Well, argued doesn't tell me which side he's on, right? It's kind of vague. Well, John has argued. Well, is he arguing for or against? We don't know. And then after that, we say he has not considered the increased traffic that will cause. Well, if we're going to use argued, we really want to know which side he's arguing, and we don't know that if we were to use that word. So that's why I can get rid of argued. As far as no change, like I said before on why we had to change it to proposed, if we use entertain, we're not getting that contrast that the sentence is setting up. So we can get rid of no change. And now we're left with suggested. So while John has suggested the idea of imposing a speed limit of 33 miles per hour, so once again, the problem with that is that it's not as strong, right? It doesn't really fit. We're indicating that someone's really proposing a policy and advocating it, and then someone's counteracting that, right? Someone is refuting that point. If you don't know what refuting is, it means basically arguing against that point, right? So if we're going to have this refutation or this rebuttal, then we have to have this strong proposed verb here, not just suggested, but proposed. So the answer there is going to be B. All right, the next question. So this is going to be a question type of homophones, and I'll show you how I know that. Anytime that I see their or its underlined, I know that it's going to more than probably 99% chance it's going to be a homophone question, right? So a homophone are two words that sound the same. So two words that sound the same but have different meanings. All right, so that's what a homophone is. They're two words that sound the same but have different meanings. I go over some common homophones down here in a minute, but for now, let's go ahead and do our practice question. So I see there is underlined. Immediately, I'm thinking that's a homophone. Additionally, when I see one word underlined at the beginning of the sentence, I'd also be looking for transitions, which I'll teach later on. Not today, though. I'd be looking for transitions if there's a word underlined at the beginning of a sentence. I'd be looking for if there needs to be a comma after it, if it's an introductory modifier, anything like that. But when I see there in particular, it could be if there is in the middle of a sentence, wherever there is. Anytime I see a homophone, I am thinking about homophones. All right, so there's three different types of there, and we're going to get into them in these A through F. Once again, you only see A through D on the SAT. This is just for practice. So our question would say, there are 15 types of beetles in America. Now we have to decide which there has to be. So in this case, they have the correct there, right? So our answer here is going to be no change, right? Now I'm going to go ahead and show you why the other answers are wrong. So this there right here, this A is possessive. Possessive, right? So if I was going to use that in a sentence, I would say, their bikes are red, right? So their bikes are red. That's indicating that there are multiple people, right? And that they own the bikes. Okay, so that's indicating there's multiple people and they own the bikes. Their bikes are red. The next there is they are. So that is an abbreviation for they are. That's why the apostrophe is there. It's taking off that A and putting in that apostrophe for it. So that's they are. So I could say they're on their way to New Zealand, right? That's they are. They are on their way to New Zealand, right? Okay, next we got no change. Next we have they are, like I said, same as there, so we can get rid of that as well. So that's how we can get rid of A, B, and D. And then E and F are its, and we know that we don't use its. Why do I know that we don't use its? Because we see that we have a plural verb, which means we have to have a plural subject. So we can get rid of its, right? And then the other thing, I'll go ahead and go over on the difference between these two its. So this right here, this bottom its is it is, that apostrophe is taking off that other I. So for example, if I was going to use this it's right here, I would say it's a nice day out. It is a nice day out, right? And then this other it's is possessive, right? So that's singular and possessive, right? So if I was going to do something singular and possessive, I would use its with no apostrophe. So an example would be, let me come up with an example real quick. The pencil's eraser is getting small, comma, and its lead is wearing dull, and its point is wearing dull, right? So that it's is a possessive and singular, right, for that pencil. All right, and then that other thing that just says placeholder, that's just so I can put a space in. You can just ignore whenever you see placeholder. It's just so I can space out my questions. All right, so common homophones that I want to cover. So here's what I'm going to suggest with homophones. I'm going to suggest that after this video, you go search common homophones on the internet. Go to Google Images, just look through a couple images of common homophones. If you don't know some of them, go ahead and look up what the difference are between them. So now we're going to go ahead and get through a couple of them. So here's a list. I'd study these ones. These ones I think are all pretty good ones that could show up on the SAT. It doesn't mean that they will, but it means that it's possible. I think that all of these are pretty common ones. You should know the difference. You should know the difference between. So the big ones, the big ones are it's, than, there. I covered theirs up there, but the other, yeah, so one of them you're going to need to know is then and than. So than is used to compare, right? So if I was to say yesterday is warmer than today, I'm going to use THAN, so that's used to compare. And then the other than, THEN, that's used for time, right? So I did this, then I did that, right? So that one's used for time. All right, next, effect and affect. I could see this one showing up on a science writing section or anything like that. So understand effect with an E, and that's what I'm going to probably say throughout most of this. And I would actually suggest you say that until you take the SAT as well. Effect and affect. Go ahead and just say the A and say the E so you know the difference. effect is a noun. So if I was going to say, an example of me using effect in a sentence would be, the effect of draining the lake is that there's less water in the lake, right? That's saying effect there's as a noun. Now if I was going to say affect, so I'm using affect as a verb, I would say let me come up with a good sentence here. Decreasing the funding for nonprofit agencies will affect their ability to help people. Right? So right there I said will affect. That right there means that I'm using affect, right, with an A as a verb. Okay? So it will affect, right? It will affect. So affect is a verb, effect is a noun. Know the difference between those two. If you can identify your subject in a sentence and your subject's right next to an effect, then that's probably a red flag and it should probably be affect, right? Because affect is a verb. So pay attention to that. And then we've got the there, and there. That's also one you need to know. And then all these other ones, I would also go ahead and make sure you know the difference. You know the difference between the two. Go ahead and Google it. If not, I don't think I should take the time to go through all of those, but I would certainly recommend looking up homophones and making sure to know the difference between them for the SAT. So if there's time at the end, I'll just have you take some time and go look those up in the last 5 minutes. All right, and then parallelism. So parallelism is probably going to be the last thing we're going to cover today, and then I'll leave correlative conjunctions for later. So parallelism, I wrote right here, it's also known as your best friend, easy money, and quick points. So what does that mean? That means parallelism should be very easy for you to identify once you've gone through some practice problems, right? At first, it might seem a little bit tough. Once you start seeing it, you're never going to be able to not see it, right? It's going to show up like a sore thumb. You're going to be able to identify the question types, and you're going to be able to find the answers pretty quickly. All right, so parallelism. You've got verb tenses, order of nouns, adjectives, and verbs have to remain the same or parallel within a sentence. All right, noun phrases have to be parallel. So that sounds kind of overwhelming at first, but it's really a lot simpler than it sounds. So I'll go ahead and show you some examples, because the best way for you to understand parallelism is with examples, because you'll start to recognize it. So these are all correct examples. All of these are correct examples. We have Haley likes to run, jump, and swim. So the parallelism part of this is run, jump, and swim. They're all verbs. They all have the same endings, and they're all the same tense, right? We want to maintain our tense, right? So all of our verbs are the same tense. Same endings is another way to tell tense. Next example we have is Haley enjoys running, jumping, and biking. Once again, we have 3 verbs. They're all maintaining that same tense. A lot of parallelism questions on the SAT have to do with maintaining the tense of verbs. So those are all verbs, all have the same tense. All right, so the next two are going to be a little bit more complicated. So we have Jason likes riding his bike, reading his book, and driving his car. So right here, what we have to match for parallelism is this verb, and then his bike, his book, and his car, right? So we have our possessive, and then we have our object, right? So possessive and object for all of them. We see we have possessive and object book, possessive his, and then object bike. All right, so that's all of those. We go verb, and then we go his, right? His showing that he possesses the object, and then the object, right? So that's also parallelism right there. And then the next one, you don't have to have 3 things to have parallelism. You can have parallelism with 2 as well, or 4, or 5. As long as there's 2, you can have parallelism. So we've got Jason never ran a marathon because he is slow, right? So we got Jason as our subject, and then never ran a marathon because he is slow, and he never rode a bike because he is uncoordinated, right? So one thing that you could see on a question is you could see a flip between something like because he rode a bike never, or something like that, right? Flipping this never to somewhere else in the sentence, or having he didn't ride a bike instead of never, or something like that. Anything that messes up this pattern, right? This pattern that we have set. We have set up a pattern of never, and then a verb, and then an article, and then a noun, and then we have a subordinating conjunction, and then we have a pronoun, and then we have a verb, and then we have an adjective, right? So we want to follow that same pattern. So if we go over here, we see we have subject, just like we had Jason. Over here we have he. Then we see we have never, just like we had never over here. And then we see we have verb. Then we go to an article. Then we go to a noun, subordinating conjunction. And then we go to pronoun, verb, adjective, right? See how all of those are the same when I went through each part of the sentence? Now, you don't necessarily have to be able to identify like an article or things like that. It certainly will help you, but if you can't, don't feel like you won't be able to get questions right. You should still be able to do it, because a lot of times the questions on the SAT for parallelism, they kind of stick out to you with the right answer. So make sure that you're looking for series, lists, or anything like that, right? Anything with these commas where there's kind of a list of things, that's where you're going to be looking for parallelism questions. So if you see a list of 3, immediately be looking for parallelism, right? Definitely be looking for parallelism if there's a list of 3. If there's a list of 2 like this and they're similar in length of each sentence, make sure you look for parallelism there as well. So any answer choices that contain lists that include verbs, right, especially lists that include verbs, are potential parallelism questions, and they probably are parallelism. They're very, very likely to be parallelism questions if it's lists with verbs. So we're going to leave off there for today, because that's about a little bit over an hour. So thanks for watching. If you appreciate my videos, there will be a donation link in the description when it's up and running. So make sure to tune in tomorrow for day 5. Thanks for watching. Make sure to like, subscribe, and share, and have a good day.